Hello, this is Jeongbin Study Room. Thank you so much for coming. Today let's try solving an interesting math problem. When I usually solve challenging math problems, I tend to inductively examine each case one by one. This approach provides important insights even when dealing with difficult problems. Perhaps our way of thinking is quite similar. So, shall we try solving the math problem using the inductive method? There are 50 residents living on one island. This island has beautiful and fragrant flowers that only grow here. Each resident grows one flower, and every day at noon, they gather in the square and then disperse to their homes. One night, a wizard appeared and cast the following spell. First, a spell that causes several of the 50 flowers to emit poison powder. Second, the person who owns the poisonous flower can detect if others' flowers have been enchanted but cannot determine whether their own flowers have been enchanted. Third, the residents cannot speak from the moment the spell is cast. And finally, the enchanted flower had an enchantment that only its owner could dispel by picking it. This poisonous flower may harm people at any time. Hence, to eliminate the enchanted flowers, the 50 residents start inspecting each other's flowers from the day after the wizard's visit. When a flower owner becomes convinced that their flower is enchanted, they return home and pluck it. On the 4th day after the wizard's visit, the islanders gathered in the square and then dispersed. That night, the residents are all able to speak and are confident that there are no more poisonous flowers on the island. So how many enchanted flowers were there in total? However, no one picked the flowers until the 4th gathering of residents, and these flowers were all picked and thrown away on the same day. Shall we try solving the problem now? In the first case, when there's only one enchanted flower, the day after the wizard's visit, the owner couldn't find any enchanted flowers among the other 49 owned by the residents. Since the residents still couldn't speak, this individual would be able to realize that their flower had been enchanted. In that case, the individual would pluck the flower on that day. Second, if 2 flowers were enchanted, then the next day after the wizard's visit, A and B, the owners of the enchanted flowers could recognize each other's enchanted flowers and think that their own flowers were not enchanted. However, when the next day arrived and everyone was still not released from the magic, the owners of the enchanted flowers began to think as follows. If there was only one enchanted flower by now, everyone should have been free from the magic. But since that's not the case, it seems that not only the flowers I see but also my own flower must be enchanted. So, that night, the 2 owners of the enchanted flower both cut it down and threw it away. In other words, according to the 2 inferences explained earlier, if there is one enchanted flower, it would be plucked by everyone on the first day. If there were 2 enchanted flowers, all the flowers would be plucked and discarded on the second day. Therefore, if there are enchanted flowers, on the nth day they will all thrown away. On the 4th day, all the enchanted flowers were discarded, and the resident's magic was lifted, so the correct answer is 4 flowers. Using induction in this way and rigorously proving it mathematically is called mathematical induction. Shall we take a closer look at mathematical induction? 1. Beginning and proof of mathematical induction. At the beginning of the solution, the proof was given for the case of one enchanted flower and the case of 2 enchanted flowers, which is a basic step in induction, verifying the initial conditions. 2. Generalization of mathematical induction. In this math problem, after solving case 1 and case 2, we generalize the induction to the general case. If there are enchanted flowers, no flowers are discarded until the nth day afternoon, and then they are all discarded at nth day night. This is where we extend the steps of the induction and establish a general pattern. 3. Conclusion of the mathematical induction method. At the end of the solution, we use induction to establish a general rule and finally conclude that it holds up to the case of 4 enchanted flowers. This is the conclusion part of induction, showing that the correct pattern holds for all given cases. Therefore, in the solution process, we verify the initial conditions and demonstrate the characteristics of mathematical induction by extending them into a general pattern. Mathematical induction is a method of solving problems by using our natural thinking skills to generalize from simple to complex situations, and it has the advantage of being much easier to come up with than deductive methods. This is why it is often used in entrance exam math and college math, and is even the favorite method of Fields Prize-winning mathematicians. Today, we explored mathematical induction and solved a problem related to it. Did you find it interesting? If you want to learn more, please follow the links in the comment. I'll be waiting for you at Jeongbin's study room.